Welcome. So anyway, to begin again, this is the data movement workshop. We're with Information Technology Services Research Cyber Infrastructure. My title is HPC Manager. My name is Ron Merrill. So here we go. Okay, so just a brief word about Information Technology Services. We are part of it, and ITS is a system level entity that provides all the really IT services on the campus, the central public services, administration, research endeavors for students, faculty, and staff. ITS is currently centrally located on the Manoa campus in the IT center. Research Cyber Infrastructure, we've been in business since around 2014, and we have grown since then. And our mission is to support data-intensive research and scholarship across the UH system with state-of-the-art resources, services, and expertise. So we focus on advanced research, computing, and data. So basically above the desktop or above the laptop kind of computing and data. The group also does science as a service, and we do collaborate with researchers on various things. And our contact information is on this page as well. So our main on-campus cluster is called COA. And again, it's above your laptop or workstation. It's free to use for anyone actively affiliated with UH. Compute servers can be purchased by researchers who have institutional funds, and they can be added to the COA cluster. We do classroom support. Currently this semester, we're supporting 7 courses at Manoa. There's a web interface and also terminal and SSH access to COA. Today, we'll be using the Open On-Demand web interface for part of our part of the presentation. On COA, there's central software modules that people can use. And if the software that you need is not on COA, you can install software yourself on COA. What is COA? It's 290 compute servers, all networked together to make a cluster. There are 152 GPU accelerators on COA. If you add up all the cores on all the servers, it's all the cores that are available to users are 9,025 CPU cores. We do offer free storage on COA. So every user gets a home directory, 50 gigabytes, and PIs can request 500 gigabytes per lab. And that lab storage can be shared among COA users within a given group. In addition, there's 800 terabytes of scratch space that's equally shared for all the COA users. The thing about scratch space is that it is ephemeral and that the files there are only, they're deleted after 90 days. So if you do start using COA and use Scratch quite a bit, you would need to set up a workflow that would transfer your files off of COA. So hopefully this workshop might give you some hints as to how you would do that. We do offer research storage, leased research storage as well. So the so-called cheap and deep scalable storage for research data we have comes in 2 flavors. In particular, COA is not is not set up for classified, for data that's classified as protected data. So you keep that in mind for anything on COA really is not really set up for protected data. Things like FERPA, HIPAA, et cetera. The two flavors of storage come as COA Cloud and COA Store. COA Cloud is a Dropbox-like storage that's powered by the open source project called Nextcloud. And I just realized that I left a door open there. Could you go close the other door? I'm not sure if I saw somebody walk in there. Thanks. Anyway, COA Cloud is a Dropbox-like storage, and you can have a remote network share, and you can sync it basically with a web client, so you can access it just basically with a browser. It's leased in 1-year increments at $55 per terabyte per year. COA Store, on the other hand, is storage that's actually on COA. So you need to be a COA user in order to access any files in that volume. It's slightly less expensive at $50 per terabyte per year. Very soon, so UH has negotiated a contract. So our CIO, Garrett Nishimi, and in conjunction with Research Cyberinfrastructure's acting director, Sean Cleveland, have negotiated a contract with Google Cloud Platform to offer discounted Google Cloud Platform services, which include GPUs, CPUs, and TPUs. And hopefully this will offer a simplified procurement and internal billing through ITS RCI. So you'll be able to shortly, hopefully, pay for those services. And it's also set up in a way that you can budget your spending, so you can't overrun your budget, which with normal cloud vendors, that's possible. So this setup, which should be available shortly, computing and national scale cyber infrastructure. So we have an instance of Jetstream 2, which is a NSF cloud. And so we have one portion, a regional portion of the Jetstream 2 cloud. So if you're interested in that, you can, again, contact us directly about it. And we also help people access HPC resource, NSF HPC resources. We help people get allocations on these resources. And so oddly enough, one does that using a facility called Access. So you gain access to NSF resources by access. And if you haven't done it already or need help doing it, we can help out in that sense. We have software developers in the group. So we do software engineering, data science, and AI. And some of the examples of things that we have here, a couple examples are State of Hawaii Behavioral Health Dashboard, which was funded by the Department of Health. And then there's also the Hawaii Climate Data Portal, which has been going on, I think, for a while and funded largely through the National Science Foundation. So access to these professional software engineers and AI scientists is a for-fee service for the most part. So if you actually need to develop something, you would pay for some of their salary. I guess maybe Shivani can say something about the graduate data fellows at this point. I'm not sure what the status of the data fellows is currently, but anyway, RCI is affiliated with Hawaii Data Science Institute. And so in the past, I know there were programs that had graduate data fellows running. So, okay, Shivani, in case you can't hear her, is saying there are 6 current data fellows. So, so other services, we have science gateways. So science gateways are bring together data, software, and resources related to domains or communities. So for instance, RCI has worked with CMYIKI to stand up a data science portal where they run bioinformatic things. And also, actually, RCI is involved in the development of some software that enables science gateways. We can also help people with data management plans, making data fair, so findable, accessible, interoperable, and reusable. And we can also help with reproducibility of your scientific results by providing container environments on COA or on the other platforms, so container environments or that allow reproducing results by having all the dependencies of the code and data all built into the container. We have a bunch of current funding and collaborations here. So I think the one in yellow is probably one that is maybe pending. But this pretty much lists I think all of the current or recent funding that RCI and that currently Sean Cleveland, our acting director, is involved in getting. The Pyron project here is actually done in collaboration with the rest of ITS. So it is a networking grant that really provides the high-speed networking for all of UH. So data transfer, that's what everybody's here for today. So besides what you hopefully will learn here, if you go back and you're actually doing your research and using COA or other resources and are having trouble moving data, or your data transfers are too slow, or you need to move a lot of data and the current speed you're getting is not good enough, you can contact us and we can, if we can't solve your problem directly, we can work with a networking group in ITS to try and troubleshoot your problem and speed up your data transfers. And this is just, I guess, a map of all the different connections around UH. So from that, we'll try to, I don't know if we want to, so hopefully everyone's here in this workshop. We had a few people come in for other things, but I'll leave it up to everybody. Is anyone interested in doing an icebreaker, or is it Friday afternoon and you'd just like to get ready to go? You could, for instance, this is Zoom's AI suggests for a quick check-in, everyone could describe one word that pretty much sums up your week so far. So anybody that wants to do an icebreaker, thumbs up. Well, going once, going twice. We have the Sean in the room. Sean, right? No. You're not Sean. Anyway, I thought you said, Okay. Checked off the wrong person. So we're not doing icebreakers. So we'll just go into the data movement modules. So um, we've got a little bit of spinning here. So when this has happened to me earlier, since I am on Wi-Fi, let's see. This is not good. There we go. Okay, so in the latter part of this, people that are interested in using rclone to transfer files, you should have installed rclone. And then perhaps look through some of these things. Also under preparation, which I won't click on, assuming that you have done this you should have some experience with the command line. And then I guess there's also some information about different kinds of file transfer that you could do. So we'll go quickly, hopefully, into the introduction to scientific data networks. How do networks connect everything? How is UH connected? And with the objectives of providing groundwork for understanding understanding how things are connected. Originally, this section was pretty much built by Sean Cleveland and Alan Winery. And in particular, Alan Winery was an expert at networking. He recently retired, but he really was pretty much of a networking wizard, if you could say, really a national resource, but local here at UH. So he goes through and talks about, you should be careful if you're buying networking equipment. Most people are probably connecting by Wi-Fi. The UH networking interconnects all 10 instructional campuses and about 40 other facilities across six public populated islands in the state of Hawaii. So UHITS maintains the commodity connectivity for the regular internet and also maintains several research and education networks. So these are separate networks, but when you connect into, when you're on COA, for instance, you're actually going out on research networks and can have high-speed transit to other research institutions that are on the research networks. So a lot of detail here, which Alan would be going through, but we'll just whiz through this. So these are what do networks look like? What does the equipment that connects everything look like? And then a brief objective of understanding the topology of scientific networks. So here's a map that shows how the Hawaiian Islands are connected to, this is the uh, New Yorker magazine view of New York, or the Allen's view of Hawaii, where Hawaii is at the center and very big compared to the rest of the world. But you can see that we have, it's a little hard to see on the size of my screen here, but we have 100 gig connections out places to the continental US and to Australia. So we have 100 gig to Guam, New Zealand, and we have high-speed links between islands. So there's some other diagrams here. There's other networks that UH is maintaining. So there's the NOAA N-Wave, Department of Energy, and then we start to get some photographs of various routers that some of them, I'm not sure whether they're still in here or whether they're probably in the data center proper over in ITC. But if you look carefully, you can see Alan's reflection in some of these networking things here. So, and then here's just a picture of Alan's hands. So there are many subnetworks that connect research, and fortunately, there is the ITS networking group currently headed by Chris Zane, who directs that group in ITS. So data transfer and evaluation of networks. There are some tools that we can use. You've probably seen some of these. Let's see. So on campus, there's a network of iPerf endpoints that measure the performance of various networks. And so you could click on these and get out there, but you can also use speedtest.uhnet.net to measure the current speed, which, since we're on Wi-Fi, there's probably not much use in doing that. Let's see, can I find? Thought I had some open, but that's okay. So that if you're having some networking problem on campus, I guess this speedtest.uhnet.net would be a good one to use. If you're at home, for instance, you could be using like speedtest.net, the Ookla speed test net. And that will give you a similar upload download speed. So again, if you're having some issues, the first thing to test is whether or not your network is any good. And so if you're connected, say on a 1 gig link, you should see a speed similar to the wire speed that you're connected to. Wi-Fi, of course, can vary a whole lot depending on many things, like just where you are, whether you're sitting next to a big chunk of metal or whatever. So what are queues and buffers? How does data actually move from machine to machine? Here's a human queue, and then here's the mental picture. You have 2 computers and a bunch of networks in between. And if you do an iPerf test, so in the iPerf tests that you might run, the data is actually held in RAM. So the fastest thing in your computer, the fastest data that you can access is in the random access memory. It's probably 100 times faster than anything else. Other than maybe the cache that's actually the cache memory that's on CPUs, but that's usually pretty small. So in the iPerf test, you would have some data held in RAM on one machine, and it would cross a bunch of networks to the other one. And so this, since the slowest thing is the thing you're measuring. You would you're cutting out any of the other problems that you could have with data transfer. So iPerf is just measuring the network and not something else. When it comes to doing file transfers, first you need to get your data off a disk and some kind of disk, whether it's solid state disk or whether it's spinning disk, it's some whole system. It has to find the file on the disk. It has to read, and that copies it into RAM, and then it goes through these TCP layers, IP layers, out presumably Ethernet, over a bunch of networks. And so there are confounding factors that lead into that. But it's even more complicated than that, in that there are these buffers in between. So if you really need to dig into some file transfer and you're having lots of problems, it probably makes sense in some ways to try and contact us, and we can sort of, especially if at least one of the endpoints is one that we have access to, that we can help you out with your data transfers. So we'll skip over the details of TCP, because those are things that Alan, for instance, and the networking group has deep knowledge about, but is probably not necessarily useful to generally. So we'll just talk about transfer programs. What are some of the most common transfer applications? So we have SCP, which is secure shell copy, secure FTP, rsync, and other SS-based programs. And so, for instance, on COA, you can access these things and do transfers that way. And so they're very accessible. They're kind of built in, but they're not necessarily super high speed. If you don't have large files to transfer, or you're basically willing to wait, the speed is fast enough, then and you already know how to use these things, then you should probably continue using those. Grid FTP is a different protocol that breaks files into small pieces and transfers as many pieces as possible concurrently. So it really is capable of filling up even high-speed networks, as long as the disk that it's getting its data off is fast enough to fill those networks out. And it tends to get better performance out of networks that have symptoms. So if you're having trouble with SCP or SFTP, you might want to use grid FTP, and one convenient way to do that is to use Globus. So depending on many factors, you may or may not get better performance out of grid FTP, but there are other aspects of what makes Globus a worthwhile thing. LFTP is a very versatile Russian origin program that features with features such as mirroring and parallel transfers. So it too can get better performance than just the single-threaded applications like secure shell copy or rsync over SSH. And then the key point is maybe secure FTP is not the best application for moving data, but again, if you have small enough files, you're not really concerned with speed, then it could be good enough. So now we'll talk about Globus. So what does Globus do? How can I use it with my data? And hopefully we'll get to transfer some data with Globus. I should say, I don't think I've mentioned it, but I don't know if they're here. if anyone has joined without using a UH ID, there's part of this. There are some parts presented today that you won't be able to participate in as a user, but you can just follow along. So Globus can be used in different systems to move data. You can use laptop, HPC cluster, cloud storage, tape archive. Currently, we don't have any tape archive here at UH, but there are other places that have tape archive where if you have access to those systems, that would also be potentially a use for Globus. Data stored at a different institution. So there are places like NCAR. There are some bioinformatics, commercial bioinformatics places that if you send samples out to have genome data or whatever, they may offer Globus as a transfer protocol. So Globus is a service that makes it easy to move, sync, and share large amounts of data. Globus will manage file transfers, monitor performance, retry failures, and recover from faults automatically when possible, and report the status of your data transfer. So if you're doing a lot of data transfer and you have pretty much with any file transfer, you need to have the same protocol at both ends of where you're transferring. So if you're downloading data from NCAR or connecting to other HPC resources and need to move a lot of data, Globus is a good way to go. There is a connector that Globus offers for Google Drive, but currently UH does not, A, it was not that performant, and B, as of a few years ago, Google Drive is no longer unlimited. So most people don't have large storage in Google Drive anymore. So in the past, there was some issues, or rather some reason that one might want to use Globus for Google Drive, but it does require this special paid for connector. Underneath, Globus uses grid FTP for more reliable high performance transfer, and will queue file transfers to be performed asynchronously. So basically, you're going to connect to globus.org, and this was developed and is currently maintained by the University of Chicago. It's over 10 years old, maybe 12 years old or so. And it is extensively used at supercomputer centers and major research facilities. So when do you want to use it? Again, if you want to transfer or share data between two Globus managed endpoints, so two multi-user systems at different universities, each running a Globus server, or between a managed endpoint, in other words, UHHPC, so COA. UHHPC is the old name. COA is the current name. And your laptop, say, you would use Globus Connect Personal Endpoint, so your desktop or laptop. We do have a subscription to Globus Plus that offers some additional features, which allows you to share data from your Globus Connect personal endpoint. So you would need to contact us to get that set up. Also, servers, people that run servers on the UH network can also set up Globus servers and use the UH license. So Globus is useful for transferring data from Mana has been subsumed by COA, so it's COA at UH. So, so if you haven't done it yet, now's a good time to, so we're going to ask, how do I create a Globus account using my UH credentials? How do I install Globus Connect Personal on my PC, Mac, Linux, or Unix. And you're going to learn to connect your UH account with Globus and install Globus on your system. It's pretty easy. So you would go to visit globus.org, click on login. Someplace here, I already have Globus open. And there's this note here, again, if you're not part of UH and are attending this, you can't really be part of the Globus subscription. And so by default, the Globus Connect personal doesn't allow data sharing. It's only if you have it set up with the license. So when you click on the login page, you're going to get the gold screen, and it's best really, although you can have different credentials for different systems that you may have access to. But for this presentation, you should go ahead and try and set up your UH account. So if the first time you're logging in, you click continue. You've already used another account with Globus. You can link your existing accounts. It turns out that when you have multiple accounts, you always have one primary account. And if you have an old account someplace else and you're coming here and you want UH now to be your primary account, you would need to unlink the accounts and make UH primary. So you would make yours UH primary and then link your other account. So you may be provided prompted for additional information such as your organization and whether or not Globus will be used for commercial purposes. Of course, you want to click nonprofit, educational purposes, and continue. You need to give Globus permission to use your identity and access information. So this is all mediated by the identity management group in ITS, which is going to provide your UH credentials. So you want to allow. And then the Globus Connect Personal turns your laptop or other personal computer into a Globus endpoint with just a few clicks. So the installation instructions are down here. You may also at some point in the installation be asked if you want to have something, if your Globus account is going to handle protected data, and you should say no, because COA is not set up for that, and therefore you would run into some issues, I think, with doing transfers. So at this point, has everybody, while I was droning on there, managed to set up their Globus account? If you're following along online, just give a thumbs up while I drink some coffee. Kaipuni says yes. We have another thumb up. And so, okay, assuming that people have all installed Globus Personal Connect, transferring data using Globus. Pretty much, you're going to end up once you've logged in with and you signed up and logged in, you're going to end up with a file manager. It looks like this. The first time you use the file manager, all the fields will be blank. And then at this point, let's see if I can find my so magically go to my setup here. And so my machines name, my collection name is Kolea, my favorite Hawaiian bird. Um, and so I have not my whole home directory, but just I've set it up so I just have one Globus Connect personal um, directory here. And so that's the only thing that where I would be transferring files in and out since I have manager in my title. I don't really do a lot of file transfer per se, but uh, also in the slides, it says UHHPC. UHHPC no longer exists, so the thing that you want to connect to is UH-COA collection. And so here I've already logged in. So once you select UH-COA collection, you may or may not have to authenticate, get in, but more or less you can go ahead and just select something. You can see over here on COA, this is actually a cleanup of my home directory. There used to be a lot more junk in there. And you can see that I have these symbolic links here are actually different volumes. I mentioned earlier, Simaiki. So these are different things. COA Scratch is the Scratch storage on COA. So if you are running on COA and generating lots of files in there, we'd probably want to go in there. But if I click on it, you'll see I have nothing. Oh, I have a file. So I'll go ahead and click it and go ahead and do start. Let's see. I'll go up one. Maybe I'm not actually connected. So let's try that again. Hmm. Did not work. Maybe because it's a 0-byte file. Let's try another one. There we go. So we got a successful transfer since the file was just something that I touched to create a stub and didn't notice that it was 0 bytes. So we actually transferred the HPC onboarding slides over to my go back to the file manager and okay. And so you can see that I have a file, this file here that's was just transferred. I'm sure I have a few copies of it over there. So I'll go back. So hopefully everyone gets that idea of that there are collections. So collections in the in the um, in the GCP basically is the same as an endpoint. So you're an endpoint and a collection, whereas something like COA has everyone's. It is, although the endpoint is called COA collection, um, everyone's files, of course, are separate, and you're only seeing your own files that you have access to. So they're essentially, there's some distinction, at least for servers, between endpoints and collections. There are other collections that we could search for here. does not match any. We'll skip that then. So presumably, if there were other collections that you were out um, out on the internet or known to Globus, let's see, let's see, is there anything in NCAR? No. Okay, well, I haven't transferred anything. So we have activity earlier. Yesterday, I guess I did some timer tests. So you can do repeated transfers. So if you were running something on Koa and wanted the results to be downloaded, you could set Globus up to repeatedly transfer all of what's in a directory to kind of keep you up to date if you wanted to follow it that way. Or, you know, that's just one thing. So there are flows also that are in Globus. So these are all things that you would need to explore on your own, where you can do transfers and set up. Globus now has some compute. There are tutorials here. I'm sure that it's a paid for service, although this Anvil is an access endpoint, so it's possible that there's some NSF funded cycles that you could do some kind of compute through Globus where you're having data flows using Globus. And these timers, I mentioned, I did a file transfer yesterday, every 3 runs of every 10 minutes, but nothing was really going on. I was just transferring the same file. So that's a quick walkthrough of Globus. Let's go back here. I guess that was totally in a different window that I run. Okay. So we requested a file transfer, and you saw me fail when it failed to transfer a file that had nothing in it. So you can go through these examples. Globus itself has lots of online information, YouTube videos. So key points of collection is a named location containing data that you can access with Globus, and collections can be hosted on many different kinds of systems. So we're only a half an hour. No, we're almost an hour in. So break time. So shall we come back? How long do we want for a break? Does anybody want to put in chat how long they want? 5 minutes, 10 minutes? Go to lunch, come back? Okay, I guess we'll go 5 minutes. So we'll try to start up again at 12:30 according to my clock. Okay, well, it's 12:30 and we're back. So let's see here. Okay. So the next part of the presentation is really using Rclone. And so the question is, how do I configure Rclone, and how do I make Rclone ready for data transfer with Google Drive? In particular, this version of data transfer workshop was just when Google had unplugged the unlimited deal for Google Drive. But of course, that's over, and currently the amount that students and faculty get is somewhat limited. You can buy more increased amount of Google Drive storage through ITS. But here we'll go ahead and presumably, in addition to um, Google Drive, there are any number of services and setups that rclone allows you to transfer files to and from. So although we're going to use Google Drive as an example today, if you have other accounts, other places that, like Amazon or Google, say Google Cloud Platform, as I mentioned, may soon be an option, or out on Jetstream or something. Setting up rclone to mount those other storages on Koa might be useful to you. So before you can use rclone, you must configure it. So I guess everyone can go ahead and open a shell on Koa. So let's see if I have. So I already have an open Koa shell, but it's probably logged me out already. So let's, I'll go back to that one. Drag him out. Where'd you go? Okay. Annoying. I had this worked out, but not working out. Okay, so basically, I've probably already been logged out here, but I'm not sure. And it turns out that I was. So if you go to koa.its.hawaii.edu, you can log in. Many of you have already done this. So and so we end up with with a shell here, where you can go ahead and configure rclone. And in the interest of time, I will like to find that other. I guess I have a bunch of it's not working. It's that one. I guess I'll just drill down into it. Okay, so basically, once you're too far. Okay, so we got a shell. Then on Koa, we're going to do rclone config. We're going to say no. We're also going to choose, well, we need to name our storage object, which yesterday I named an object, not rclone G drive, but something else. So the actual command would be rclone space. Well, yeah, you're typing in rclone G drive. So then choosing the storage option. In this example, it lists Google Drive as number 18. It's currently number 22 that you would select. So you'd go ahead and answer this storage question as 22, setting your own is recommended. Let's see how to create your own. If you leave this blank, we'll use an internal key, which is low performance. I leave this blank in the tutorial. It's a client secret that you also access. And so you're going to want to select full access. For the scope so that you can read and write with this. So here, when you get down to scope, it says 1. Kind of just winging through this as we go, but you should be able to do all of these steps from this Koa shell. And then ultimately, it's asking, let's see, enter string, service account, and then edit advanced config, you say no. In the tutorial, we're running rclone on a remote machine. And so this is the somewhat tricky part and weird part, is that the rclone that you set up on your own machine is how you're going to get the, essentially the key that you're going to put on Koa. And you're going to do that by entering this rclone authorize name of the drive, this thing. So if I go over here to my terminal, I've done this in the past, so I'd be doing this, hitting return, and I'm going to get this big long key. Well, I'm going to, a browser is going to launch, and then in the window, you're going to select your user and give rclone access to your Google account, and then you'll see a success thing. And then back in the CLI on your machine, you're going to see this really long token. Then back on Koa, you're going to do a config, rclone config. You're going to config token in rclone and paste that in. So are people following along on this, or should I be doing more actual manipulation, which I've already set up? So back on Koa in the shell, I'm still here. That's another thing about Koa currently. If you're not typing into the shell, it's going to log you out fairly quickly, but you're still connected. I'm clearing my my display here on the shell with Control L, and I can close this other thing. And so there, if you just do rclone, it's built in on the login nodes, and you can see that although we don't go through it here, there are actually a whole bunch of commands that you can use. So you could basically see what version you're running, and in the tutorial, you're also going to be able to do an LSF to look for files. So let's see. So here, if you followed along, you can do an rclone LSF and then see what's in rclone G drive. So you can actually see the files that are in your G drive if you followed along all of these steps. I called mine something different, and that's the wrong tab. So I can, so I could do, and so you can see that I set up test rclone G drive, so I could do rclone being super lazy. Nope, I missed. I'll just type. And some of the things I tried to clean up yesterday apparently didn't get cleaned up. So this is my cleaned up G drive that you're looking at. There's a lot more junk in there, but there's still plenty of junk in there. So at 12:45, has everyone or anyone managed to get through? Is anyone having a problem that you want to try and address? Let's see, we have comments here. Oh, no, we don't. So that's basically how you can see what's on your Google Drive or other storage that's off of Koa. So you can mount it on Koa. And so now we can create a directory, let's see, to transfer files to and from Koa G drive. So here you're actually going out on your G drive and creating something, but I will just go and let's see. So basically, in the example, you're going ahead and transferring files to and from Koa using rclone. So if you want to run something in the background, you would do this no hup. Mention rclone, you're going to copy a source to a destination where on Koa, the source would be whatever file or directory you wanted, and then the destination would be, in my instance, this, in your instance, it would be rclone G drive, and then whatever whatever directory you wanted to get into there. Is this making sense to people? So in terms of other examples, let's see. Has anyone successfully installed and transferred files with rclone? I see one yes. No, not yet. What in particular are you stuck on, or is there some aspect of the setup that I swung through too quickly? Let's see. Okay, so we have one person in IFA that's running on a headless machine. Not sure what the client secret is. Okay, so I yeah. So technically speaking, let's see, client secret. Are these uh, yeah, I guess these things are actually not text, but they're unfortunately um let's see, they're unfortunately images in here. So have a question about client secret and then also about running from a headless machine. Uh, I see it in my terminal, but not in the module. Um, yeah, I'm having a hard time. I think you just hit return on that. Let's see. Configure this as a shared team drive. No. Um, it's possible that that there's some that there's something missing. Let's see. Someplace I had. That's notes. Okay. So option client secret off, leave blank normally. So that's just another one that you hit return that then gets you to this scope. Does that answer your question, Kai Puni? And so far as the headless install, I would imagine that there is a way to do a headless install, but I don't know. This presentation is really just pointed at doing this kind of install for Google Drive connected to Koa. Um, So, so in principle, if you had gone through this, you would be able to transfer files with a copy. I think at this point, we're about 10 minutes out, and there should we go ahead and do we can, and unless there are questions that we think can actually be answered in this. So some people were able to follow, and for those that uh, can't or haven't been able to do it, we can go ahead and help you out to follow through again. But for those that successfully transferred files, um, we could go ahead and ask that you do this participant survey. So there's either just point your phone at the QR code, or you can go to gohawaii.edu/R_AM, which is the shortened URL for the participant survey. So for everyone that is having issues here, I would say, so hopefully everyone has the participant survey. Let's see, I would say go ahead and contact us either at this ITS RCI with your problem. Because as I said, my Rclone experience was what I did yesterday. And so it really is, my experience is pretty much limited, but clearly so this business of the two-factor authentication and how you get around it, I'm sure there is a way to do it, but I'm not sure how you do it and why on Google Cloud Platform, the other GCP, not Globus Connect Personal. So I'm not sure how to do it, but if you shoot us an email, we can look into it and get back to you. And similarly, if you with the headless machine problem, shoot us an email, or I can just take your input from chat here and try and go look these things up and consult with my colleagues to help me out on this. Okay, so we have one person saying, thank you. I'm going to see if I can utilize HPC for a chatbot project. Great. So I think Noah is a student of ours, so that's good.